And these small, seemingly tiny gaps can have huge consequences. They can totally warp our findings, they can weaken our statistical tests so we can't be confident in our results, and they just make the whole process of finding clean patterns an absolute nightmare. It is a fundamental, rock-solid problem in data science.
So, for years, researchers have come up with two main strategies for dealing with this villain. It really all boils down to two philosophies. The first one is called imputation, which is basically a very sophisticated form of guessing to fill in the holes. The second is called direct adaptation, which tries to ignore the holes and just force PCA to work around them. Now, this guessing approach, it's gotten incredibly advanced, with really powerful models like GAIN and mice, but there's a fundamental danger here. Think of it like a book with a torn page. If you try to guess the missing words, hey, you might get the story right, or you might completely change what the author was trying to say. You run the risk of analyzing your own assumptions, not the actual original data. The ignoring strategy, that sounds a little safer, right? Just work with what you got. But it turns out these methods can be incredibly fragile. When a lot of data is missing, they can become super unstable, or even worse, produce results that are just mathematically impossible, like a negative variance. They're just not reliable when the going gets tough. And this leads to a pivotal question that just changes the game entirely. Instead of guessing the missing words on the torn page, PCAM analyzes the writing style from the pages we do have to understand the author's true intent. It works with the evidence, not with assumptions. And it pulls this off with this really elegant two-step process. First, you have the fit phase. This is where it studies the incomplete dataset and learns its statistical DNA, its core underlying structure. Then you have the transform phase, where it uses that knowledge to intelligently place any new data point, even one with missing pieces, onto that simplified map we talked about. And the projection itself, this is the most clever part. Instead of filling in the blanks, PCAM uses the data it can see to make a highly educated statistical estimate of the effect of the missing values. It's not inventing data to fill a hole, it's calculating their influence on the final result. It's just a much smarter, more direct path to the answer. Okay, the theory is fantastic, it's beautiful, but in science, you have to prove it. So, does our new hero actually win the fight? Let's look at the data. Now, the setup for this test was absolutely brutal. The researchers deliberately removed half, 50% of the data. And yet, look at these results. Across three very different datasets, PCAM is consistently at or right near the top in accuracy.